Here is 25th question of evaluating limit, and the question is like this: limit when x tends to 0, find the value of f of x, where f of x is absolute value of x divided by x when x is not equals to 0, and 0 when x equals to 0. Okay, to solve this question, this will be really one of the conceptual question again for you. Very informational video it will be for you if you are learning limits and derivative. So please keep in mind, I'm gonna first explain what is this absolute value. All right, what is this modulus value? If my function is, let's say for a while, f of x equals to just modulus value of x, if this is my function, then the graph, if you go for the modulus value, is something like this. This is at 0, right? This is the graph of the function f of x equals to modulus value of x. All right, this is your y-axis, this is your x-axis. All right, this we see y also. So what does it mean? Y equals to f of x equals to absolute value of x. It has three value, x, minus x, and 0. When x is greater than 0, when x is less than 0, and when x equals to 0. From our childhood, we have been learning that modulus value of any kind of thing is always positive. Modulus value of negative numbers, positive numbers, anything, always we get positive, right? But how does it work? Let me tell you the mechanism of that. Let's say I'm going to take for a while minus 3, and I will take plus 3. All right, how does it get positive? You say modulus value of minus 3 is 3 and modulus value of plus 3 is 3, but how you get this plus 3 when you were when your x was negative of 3? All right, this time if you see, this minus 3 is my x, and this time if you see, plus 3 is my x. All right, so when I'm minus 3, as I told you, minus 3 means this side I'm going. All right, let's say this is 1 2 3 for a while, this is your minus 3. So when x is less than 0, minus 3 is less than 0 means I'm this side, then that time you have to multiply by minus and whatever your x is. It means you have to multiply by minus and whatever your x is, and x is here minus 3 times minus 3. So that's why you're going to get positive 3. This is the reason you get modulus value of any negative number as a positive. So it's positive 3. And again, here this time x is here plus 3. All right, so let's say 1 2 3 for a while, this is x equals to 3. And as I told you, when x is greater than 0, means this side, then you have to just write the number. So I'm just writing that number, I'm writing here x, and here I'm just writing x, and x is here plus 3. So that's why whether the modulus value of negative 3 or positive 3, always you get positive 3. So based on this concept, we need to find out the limit of this function when x approaches to 0. So x approaches to 0, here x equals to 0, and x approaches to 0, it means x is not equals to 0, x is slightly less than 0. All right, if it is slightly less than 0, then we are this side. All right, it is left hand side of the this origin, and if it is slightly greater than 0, then we are right hand side of the origin. All right, so we have to now find out the approaching value from the left hand side as well as from the right hand side. When we find out the approaching value from the left hand side, that we say left hand limit, and that is limit x tends to 0 minus f of x. Right, and that's going to be again limit x tends to 0 minus, and the function, see, when x is 0 slightly less than 0 means it's not equals to 0. All right, we are not going to take this, it's not equals to 0, it's slightly less than 0. So whenever x is not equals to 0, we need to take this one. So modulus value of x divided by x, and as I told you, when it is 0 minus, it means slightly less than 0, it is in this side, and whenever it is this side, which one you need to take? You need to take negative of x. All right, so limit x tends to 0 minus negative of x, I just remove this modulus value, modulus sign, divided by x, x cancel, and you get simply minus 1. This is 1, so you just simply get minus 1. So your left hand limit is minus 1. It means that when we are approaching from left hand side, we are going to get the functional value of this the approaching value of this function f of x as a minus 1. All right, now let's approach from the right hand side. What happens when we approach from the right hand side towards this 0? All right, let's find out that, and that we say right hand limit, and that is limit when x tends to slightly bigger than 0, 0 plus f of x. Again, it's not equals to 0, so we have to choose again the same function. That's limit x tends to 0 plus absolute value of x divided by x. And as I told you, whenever our x is greater than 0, whenever x is greater than 0, we need to just write that x. So we are just leaving this. All right, limit x tends to 0, just x, it is greater than 0, so just we'll write x divided by x, x cancel, times 1, so it's simply 1. Oh my god, here our right hand limit is 1 and left hand limit is -1. And to finish this question, I have to ask you a very simple common sense question. Do you think Anil, at one single time can be at two places? Means at single time, can I be in a school also and can I be in my home also? Not possible. A single guy cannot be at two places at single time. It's not possible. So how can you suppose that the value of a function at one particular point can be 2? Then how it is possible that our function f of x can have two different value when x approaches to 0? When x approaches to 0, our function cannot have somewhere +1 and somewhere -1 at the same point. When x is approaching to 0 means when x is almost equals to 0, the function is having +1 and -1. When we approach from the left hand side, we got -1, and when you approach from the right hand side, we got +1. So a single point cannot have the two different value for a single function. So that's why here left hand limit and right hand limit is not equal, resulting us that limit does not exist when x approaches to 0. Very simple. Alright, always my dear friend, always you have to check out whether the value of the function while approaching from left hand side, while approaching from left hand side and while approaching from right hand side to the same point is equal or not. If it is equal, then that's great. If not, the function, the limit of that function at that particular point does not exist. Alright, I will see you guys in the next video with next very good concept. Till that time, bye bye.